In this video, I'm going to be talking about problem solving for accelerated motion. So we have two example problems and three kinematic formulas to the left-hand corner that all have to deal with acceleration. So let's go ahead and talk about these three steps before we get into the problem solving. Number one, you want to write your known variables. So you have to read your sentence, make sure you interpret the situation, and you want to find three variables. So why did I say three? Is because if you take a look at each of these three main acceleration formulas, each of them have four variables. So if you have three of the four, that means you could find the fourth by using some algebra. Number two, find the equation with the desired variable that has the variables from step one. So if you're looking for, say, a final velocity, then obviously you need a formula with a VF in it to solve for that final velocity. And then you want to have those three known variables that match up with it so that you're going to have to do some steps of algebra and then go ahead and find the answer from there. And then number three, set up as shown in the equation and solve. So place things exactly as you see it in the format that you see it with the formula, and then go ahead and simplify it and do the algebra from there. So you're going to see how the process works with these two examples. So let's go ahead and get into the first one. The first one says a car is going 30 meters per second and then slows down to a speed of 15 meters per second. So it sounds like I have my initial velocity of 30 meters per second and my final velocity of 15 meters per second in 6 seconds. And then we have a time of 6 seconds. So we're going to use the context of the sentence, and we're definitely going to check out those units to make sure we are labeling our variables correctly. What is the car's acceleration and how far does it travel during this time? So it's also important to write down what you're looking for. So I'm looking for acceleration first, and then I'm going to be looking for a delta x second. So I'm going to look at my formulas. I want something with an A in it, which doesn't narrow things down much because these are all acceleration formulas, because there's an A in this one, and this one. People would have the tendency to use the first one because it's set up nicely. So let's go ahead and take a look at that one. Do I have VF? Yes. Do I have VI? Yes. Do I have time? Yes. So I have the three known variables, and it has the desired variable that I want, which is the A. If that one didn't work, then I want to go ahead and look at one of my other formulas, and it is very likely that one of those is going to work out. So let's go ahead and solve for the acceleration using that first formula. Okay, so I went ahead and plugged in my three known variables. I didn't have to do a whole lot there because the formula was already set up for A, and A was already isolated. I want to make sure that I put my VF in front, and then I subtract my VI, which gives me a negative 15 up top, divided by the 6 seconds, and that gives me negative 2.5 meters per second squared. Now I'm looking for a delta x, and for this one, it's going to be pretty easy, because I can either use the second formula, delta x equals all of these variables, or I can solve for delta x in this formula. The reason I know I can use either one is because at this point I have every variable except delta x. I have VI, VF, T, and now I have A. I'm going to go ahead and use the second one because it's already set up with delta x isolated, so I like that, so I don't have to do any algebra. So I'm going to go ahead and plug in those numbers and then solve for my delta x. All right, again, I didn't have to do too much algebra there. I just took the product of these two. 30 times 6 is 180 meters. And then in my calculator, I put 0.5 because I like to put the 0.5 instead of 1 over 2. It's all the same, so 0.5 times negative 2.5. And then made sure I put that 6 squared in parentheses so that doesn't square this entire value altogether. And then that gave me negative 45, so 180 minus 45 gives me 135 meters. Okay, so you can see there for the first example, it didn't require a lot of algebra, just a lot of reading, interpretation, organization, and then finding the right formula by seeing what variable you're looking for and what variable you have. All right, for our second problem, we have a woman jumps off the ground with the speed of 5 meters per second to her peak. How high does she rise off the ground? It sounds like she has an initial velocity of 5 meters per second. Because she's in free fall, she's moving freely through the air, but neglecting the actual air resistance itself. It is negative 9.8 meters per second squared. And then we have a third variable that we're looking for because we want to find three variables, but we don't seem to have three that are clearly given in the problem. So you're going to do one of two things when you're missing your third variable. The first thing you definitely want to do is look for a variable that is implied, which oftentimes is a zero. If something is starting at rest, you have a zero. If something is ending at rest, you also have a zero. In this case, something is rising to its very peak, and once it reaches its maximum height, its instantaneous velocity at the very end is 0 meters per second. Okay, so you try to find a zero if possible, and if not, then you may have to use a second formula in your whole problem solving process to help you find that third variable. And now I'm looking at the question. It says they want how high does she rise off the ground, which is a delta x, or that could be called a delta y because it's a change in the vertical position. But either way, we're solving for the displacement. So I'm going to look at my three formulas. Definitely not this one because I don't have my time. And then this is a formula that involves time in two different spots. I'm taking a look at this one, the other formula with the delta x, and I'm seeing if I have the other three, the VF, VI, and A, and I do have all those three. So I'm going to go ahead and set that up and solve for my delta x. All right, for this one, I did have to use a little bit of algebra. So on this side, I have 0 squared, which is going to be 0. And then I have vi squared, which is 5 squared, which is 25. And then I have 2 times negative 9.8, which is negative 19.6, which is the coefficient in front of the delta x. And I want to make sure I move one thing at a time. So I'm going to go ahead and scoot over that 25. So I subtracted 25 from both sides. So I have negative 25 equals negative 19.6 times delta x. Divided both sides by that negative 19.6, which gave me a positive 1.28 meters because the woman is rising off the ground. So whether you're a naturally good problem solver or not, if you follow these three steps, it will consistently make you more effective if you write down the three known variables, keeping everything all nicely organized in the beginning, writing down what you're looking for, and then go ahead and finding that proper equation out of the set of formulas that we have, so that you can plug your numbers in. And then for the very last one, plugging the numbers in as shown exactly in the formula, so that when you write everything out, it's going to be nicely organized. All you're going to have to do is kind of clean it up a little bit, do a little bit of algebra, and then that will take you to your final solution. So I hope that was helpful in helping you problem solve with accelerated motion. Thank you for watching and listening.